All right, deductive proof, section 5.6. It says in 1 Corinthians 15:13 through 20, Paul used a form of deductive reasoning to conclude that there is a resurrection from the dead. Deductive reasoning is the type of reasoning you will use most often in geometry and other math classes. Since deduction is used so frequently, this section is devoted to different types of deductive reasoning. Deductive reasoning can be split into two major sections: proof by direct argument and proof by contradiction. Some of the kinds of direct argument proofs are given below. So we're going to look at these today: the law of deduction, modus ponens, modus tollens, and transitivity. I would say that if you guys seem to be doing pretty good practicing the contrapositive and the inverse and things like that simply by looking at the symbols. If you can just kind of keep in the symbolic mind here, these will make pretty good sense. All right, so let's take a look at definition. A law of deduction is a method of deductive proof with the following symbolic form. So it starts with some sort of P statement, which is an assumed statement. From there, you're going to put another statement and another statement, however many you need. These should be underneath here, but I don't know, they put a column too. So QN just means it doesn't, you don't know how many statements you need, N number of statements, but it could be a lot. At some point though, you are going to deduce something from the statements above. And so you're going to get to say, if this was true, then R. And so you're going to write that. If P, then R, just for your conclusion. So that's what I'm going to show you, just a little example here. It says if. Notice this is an if, then. So we're going to have if is going to be something that you get to assume. If you can finally get to this line right here, which is the second to the last line, it's always the second one. So if this, and you work it, then it shows up what you were trying to get, then you get to state at the last line, if P, then R is a fully true statement. You kind of just get to leave the middles out. If P, then R, and your reasoning is because of the law of deduction. So we've done some proofs already. This says if T is the midpoint of SV, then ST is half of SV. So if T is the midpoint here, then this portion ST is half of the full thing. That seems fine. So you get to assume that T is the midpoint. If T is the midpoint, you're able to say that ST and TV are equal. This portion's equal to this portion. And we also get to, and that's because of the definition of midpoint. Definition of between, because we also got that T is between. You could add this part plus this part to equal the whole thing. That's the definition of between. Substitution is where if you take, notice here that we have ST plus TV equals SV. Now these two lines are exactly the same, except I can see that this part right here is different. So how are they able to say the same exact line, but they swapped out an ST for a TV? Well, because this line right here says that they're equal. So we're able to swap them out, so that's why it's substitution. Now ST plus ST is 2ST. That's the change in this line. We talked about that. It's the distributive property. Then what happens is this is a 2ST going to an ST. SV, half SV. It looks like they divided both sides by 2. So dividing is actually multiplication, right? So it's the multiplication property of equality. So we got what we wanted. We said if T was the midpoint of SV, which is what we started with, then we would get that ST is half of SV, and we found that. So you restate it saying if T is the midpoint of SV, then ST is half of SV. And you get to just put the full thing all together and just say that your reasoning for that is the law of deduction. All right, down a little lower it says, if you understand the law of deduction, you should be able to understand the proofs in the rest of the book. To prove the conditional, if P then R, you must assume that P is true and then show that R is also true. Okay, that's exactly what that example was up there. So just read that again. If you're trying to prove a conditional, if P then R, start by assuming this is true, show that R is also true. Let's take a look at what they call a modus ponens. Probably have never heard of those words. It says it's a method of deductive proof with the following symbolic form. So you're going to have an if P then Q. Let's look at what it says. So if, I can do this one. If you get straight A's, then I will buy you pizza. P, that means P happened. You got straight A's. Conclusion, I will buy you pizza. You could see that if P then Q, it starts off with stating the P. That is a fact. Okay, we're trying to prove things, so these should be true. If P then Q, P is true. Well, if P then Q. So if P is true, Q. That's your final conclusion there. So let's take a look at another one. Okay, classify this argument. If a man is sinful, then he must die. Man is sinful. Isn't that the P? Right? So we could put up here, if man is sinful, if P, then Q, right? So the modus ponens that we just studied had the first line was an if P, then Q. The second line was a P, and that's exactly what that is. Man is sinful. This next line was the Q. So if man is sinful, man must die. If man is sinful, then he must die. So you could see, it says this argument has the form of modus ponens. You can see the form if you reduce it to P's and Q's. Then you can see it. It follows a pattern. It says, therefore, it's valid since it's based on true biblical premises. It's also sound. Okay. We're going to look at... we can read this. If it is wonderful that the Bible gives us a remedy for the fearsome conclusion found above. The remedy is found in Romans 10, 9 through 13. So here's an if-then statement. If a man will confess the Lord Jesus Christ and believe on him, then he shall be saved. So if P, then Q. So the next statement is just P. If a man will confess the Lord Jesus Christ and believe on him in his heart. So that would say P. The man asked Jesus into his heart. The next statement is Q. It was if, then, if happened, Q happened. That's how it works. You can reduce that to symbols and see that also. Let's go with this one down here. It says if, it's a totally different type. It's going to be a modus tollens. We're going to learn that one, but let's read it. It says, the form of deductive argument that Paul used in 1 Corinthians 15, 13, and 20 is called modus tollens. So it says, if there be no resurrection of the dead, then Christ is not risen. Okay, if there be no resurrection of the dead, then Christ is not risen. I know it says it, then is Christ risen, but it's not a question. It's how the Bible reads. If there be no resurrection of the dead, then Christ is not risen. So let's just think about what that means. So if nobody can rise from the dead, then Christ didn't rise. That's what it's saying. But premise number 2 said, now is Christ risen from the dead. That means he did rise from the dead. So if there's no resurrection, then he didn't rise from the dead. But he did rise from the dead. The conclusion is that it can happen. There is a resurrection of the dead. So let's take a look at reduce it down to symbols. And you might just need to turn me off and look at it and study it yourself. Maybe without an explanation, it can sink in a little bit. But we have the very first line is if P, then Q. If P, then Q. Your second premise is going to be that Q did not happen. So if Q did not happen, then P could not have happened. Hopefully you get that. It's a if this happens, then this happens. But this did not happen. Therefore, this did not happen. So maybe we'll just take a look at it right up here one more time. So if there's no resurrection from the dead, then Christ is not risen. Christ did rise, so there is a resurrection from the dead. That's it in symbols right there. That one's called modus tollens. Okay, and our very last one is called transitivity. And This just is something that I feel like we've used a lot already. If P, then Q. If Q, then R. Then you can make the connection if P, then R. I'm just going to skip down here. Be careful to use these 4 deductive proof methods correctly. 2 fallacies result from common misuse of modus ponens and modus tollens. These fallacies are assuming the converse and assuming the inverse. Okay, so if you remember what a converse is, and remember what the inverse is. If you don't remember, I'll put those in here. Okay, here is the converse, the top one. And the converse of if P then Q is when you switch them around and say if Q then P. So you might end up doing that on accident. And then if you take a look, it says another common one is assuming the inverse. And that one is instead of if P then Q, you say if not P then not Q. And it turns out that neither of these is the same. Like this and this are not the same. This and this are not the same. And it says, if you keep reading or remember from the other day, the contrapositive is the only one that's equal to the original. If P then Q is actually equivalent to if not Q then not P. So if you're trying to use the other two, you'll end up with a mess on your hands because it's not logical. So I'm going to go back to the other one and we'll take a look at those mistakes. All right, example number 3, it says classify the fallacy. So the fallacy is going to be the assuming the converse. And if you remember, the converse is switching the P and the Q. So it tells you that, okay, all dogs are mammals. Fido is a mammal, therefore Fido is a dog. It says you have to symbolize the argument. So I'm going to actually break up dogs and mammals. Let's say an animal is a dog. That's going to be the D statement. And then mammals are M. So if an animal is a dog, then it's a mammal. So if D, then M. If an animal is a dog, then it's a mammal. Fido is a mammal. So we're saying mammal happens. Okay, there it is. And it says, therefore, Fido is a dog. So therefore, the dog shows up. So you just take a look at this. It says if D then M. You state the M, so you're assuming D. That's your conclusion. But what I want you to look at is this one right here. If P then Q, you have to put your statement of P next. And then Q comes after that. But instead, in that one, you put the Q there, and then you put the P there. So you switch the P and the Q. When that happens, oops, I'm on the next page. When that happens, you're switching the P and the Q. It says this assumes the fallacy of assuming the converse. So hopefully that one made sense. It says, likewise, the argument below contains a fallacy, though it may first remind you of a modus tollens. The name of this fallacy is assuming the inverse. So if you have all dogs are mammals, okay, Fido is not a dog, therefore Fido is not a mammal. So we have dogs and mammals again. If an animal's a dog, then it's a mammal. So if D, then M. Not D, so that's why we have Fido is not a dog. Not D. Therefore, not M. And the problem that you run into here is the inverse. And inverse, if you remember, the inverse of if P, then Q is if not P, then not Q. And unfortunately, those two are not the same. So even though you went along this route here of that pattern, it doesn't mean the same. So anyhow, I think the first page, the rest of page 193 has some really good thinking questions. I can go over some of these with you if you have some questions, but hopefully page 193 is something that will come easy to you, or at least make some sense. The rest of it, we'll see. Good luck. All right, that's section 5.6.